Graphing linear equations from standard form. So we have learned, right? We can graph equation from a slope-intercept form that says y equals mx plus b based on the m and based on the b, right? Which is the slope and the y-intercept. Standard form is ax, where a is some kind of a number usually, times the x, plus by, where b is also some kind of a number, times y, and that equals c, and c is also going to be some kind of a number. So this is kind of another way to graph equations from standard form. So we know at this point that we can graph from a slope-intercept form. So if I see an equation written in a standard form, I can either graph it by converting the equation that is given to me in a standard form, ax plus by equals c. I can convert the equation into a slope-intercept form. And the slope-intercept form is y equals mx plus b. That means I will have to isolate my variable, right, and move everything away. And once I have something into that form, we all know how to graph it. The second way I can graph a line from a standard form is if I was to replace or substitute, right, x with 0, and once x is a 0, it's going to be gone, right, and I would be able to solve for y after that. Once I have my y, I will go back to the original equation, and I will replace, or I will substitute 0 in for y. And once I have y is a 0, that will disappear. Then I will be able to solve for x. Then I will know what is x equal to, that would be my 1 point. I would know what y is equal to, that would be my second point, right, on a y-axis. And then I could connect those 2 points and I have a line. So if I have an equation in a standard form and I have to graph it, if I have 3x, right, minus 4y equals 12, I can actually use the first way, which is use the slope-intercept form, right? That means slope-intercept form says y equals mx plus b. Well, if I rewrite that equation, I know I have to keep my y alone. So I have to move a lot of things away from the y, right? Now if I look at the 4 is attached to the y by a multiplication, and I know the 4 is going to be the last thing I will be undoing then. So I have to move the 3x from one side of the equal sign to the other side of the equal sign, and the way to move it is subtract it, right, from both sides. 3x minus 3x is a 0. I still have my minus 4y, equal sign, 12 minus 3x. Cannot combine the 12 and a minus 3x, right? I'm still solving for y. I want 1y, that means divide by negative 4 every single term I see. Negative 4 divided by negative 4 is 1, so I have 1y equals 12 divided by negative 4 is negative 3. Now look at that, double negatives, right? What happens when I have double negative? That becomes positive, and I'm going to leave it as a fraction, which is 3 over 4 times the x. Remember, I want the number before the x as a fraction because that is my slope, right? The number before the x is my slope. And then I have the negative 3, which is my b, and that is the y-intercept. And what do we know? Y-intercept, right? The b is the first point on my coordinate plane, and that's the first point that I will plot on the y-axis. And then I have a slope that is going to tell me how do I go from my first point to the next point. And it's positive 3 units up, and 4 units over. So here is my -3, my first point, right? My B, y-intercept. I go 3 units up, 4 units over. There's my second point. Now I can create a nice line, right, through those points, and that is the graph for the equation 3x minus 4y equals 12. Now let's look at it if we can apply the second way. The second way said, right, we will substitute 0 for x, for instance, and then we're going to be able to solve for y. So let's substitute 0 for x. So I have 3 times x, which is 3 times 0, minus 4y equals 12. Well, 3 times 0 is what? That's 0. So now that thing is gone, and I'm left with negative 4y equals 12. I want to know what y is equal to, so I have to divide both sides by negative 4. Negative 4 divided by negative 4 is 1, so I have 1y equals 12 divided by negative 4, which is negative 3. So I have a point on y-axis on negative 3, because y is equal to negative 3, right? So there's my point, negative 3, which represents the y. Now let's replace the y with 0. Let's substitute 0 for y so we can solve for x. So I have 3x minus 4y, we're substituting in 0 for the y this time around, equals 12. Well, 4 times 0 is what? 0, so that's gone. And I'm left with 3x equals 12. I'm solving for my x, so that means I want just 1x, divide both sides by 3. 3 divided by 3 is the 1x. 12 divided by 3 is 4. So that is my second point that I need, and that is on an x-axis that equals 4. Now I'm going to put a nice line through these 2 points, and voila! Same line, 2 ways, got it right both ways. And that is it.